Hi students, good morning to all. It's me, Vinod Joseph, your maths teacher. Are you okay? I hope that all are happy and safe at home. Have you remember the last class? Yes or no? Yes. Last we discussed remainder theorem. What was remainder theorem? Anyone can you remember? Remainder theorem. That is P of x is a polynomial of degree greater than or equal to 1 and a is any real number. If P of x is divided by x minus a, the remainder is P of a. That we discussed and we completed some questions. Today I am coming with a new topic, factorization of polynomials. Factorization of polynomials. And from this topic, first consider a polynomial P of x. P of x is a polynomial P of x equal to x cube plus 1. Now, we are going to check whether the polynomial P of x equal to x cube plus 1, it is a multiple of x plus 1 or not. P of x is a multiple of x plus 1 or not. We are going to check the polynomial x cube plus 1, it is a multiple of x plus 1 or not. As you know, this polynomial P of x equal to x cube plus 1. As you know, x cube plus 1 will be a multiple of x plus 1 only if x plus 1 divides x cube plus 1, leaving remainder 0. Now taking x cube plus 1 equal to 0, x plus 1 equal to 0, we get x equal to minus 1. Also, P of minus 1. P of minus 1 equal to, substitute x equal to minus 1, that is minus 1 cube plus 1, that is equal to minus 1 cube. What is minus 1 cube? Minus 1 cube is minus 1 plus 1. Minus 1 plus 1 we know it is 0. P of minus 1 equal to 0. We got P of minus 1 equal to 0. So, we can say that the remainder obtained on dividing x cube plus 1 by x plus 1 is 0. The remainder obtained on dividing x cube plus 1 by x plus 1 is 0. So, x plus 1. So, x plus 1, it is a factor of x cube plus 1. X plus 1 is a factor of, it is a factor of x cube plus 1 and x cube plus 1, it is a multiple of x plus 1. First we can say x plus 1 is a factor of x cube plus 1, at the same time x cube plus 1 is a multiple of x plus 1. So, we can write x cube plus 1 or P of x or P of x, this P of x equal to x plus 1 into g of x. X plus 1 is a factor of the polynomial P of x. So, we can write P of x as x plus 1 into g of x for some polynomial g of x. So, once again P of x we check P of x is a multiple of, it is a multiple of x plus 1 or not. By substituting x equal to minus 1, we got 0. So, the remainder is 0. So, we say that x plus 1 is a factor of x cube plus 1 or x cube plus 1 is a multiple of x plus 1. Now, we are going to discuss a theorem. Our second theorem, factor theorem. Let us see. Last class we discussed remainder theorem and now we are going to discuss factor theorem. These two theorems are very important. Proof also given. You have to learn it thoroughly. First statement, factor theorem. Factor theorem says that P of x is a polynomial of degree n. P of x, it is a polynomial of degree n that is greater than or equal to 1 and a is a real number. Then first one is x minus a is a factor. X minus a is a factor of P of x. What is the condition? If P of a equal to 0. Theorem says that P of x is a polynomial of degree n greater than or equal to 1 and a is a real number. A is a real number. Then first one, x minus a is a factor of P of x. X minus a is a factor of P of x if P of a equal to 0. Then second one, P of a equal to 0. P of a equal to 0 if x minus a is a factor. X minus a is a factor of P of x. So there are two conditions. This is a statement of factor theorem. Once again, what is factor theorem? Factor theorem says that P of x is a polynomial. P of x is a polynomial of degree n that is greater than or equal to 1 and a is any real number. Then first one is x minus a is a factor of P of x if P of a equal to 0. Second one is P of a equal to 0 if x minus a is a factor. So we are going to prove it. How to prove this one? Proof of this statement. Proof of factor theorem. What is the proof of this one? So first we are going to start with the remainder theorem that we discussed last class. We know that what is remainder theorem. We know by remainder theorem P of x, the polynomial P of x equal to x minus a into q of x plus P of a. That is remainder theorem. We know the remainder is same as P of a that we discussed. So P of x equal to x minus a into q of x plus P of a. That is the remainder theorem. Now first condition, x minus is a factor of P of x if P of a equal to 0. Now we are going to substitute if P of a equal to 0, what do you get? P of a equal to 0. Then we get P of x equal to x minus a into q of x. If P of a equal to 0, then P of x equal to x minus a into q of x, which shows that x minus a is a factor of P of x. Okay, so we proved the first one. Then second, since x minus a is a factor, since x minus a is a factor of P of x, it is a factor of P of x. X minus a is a factor of P of x. So we can write P of x as P of x equal to x minus a is a factor of P of x. So we can write P of x equal to x minus a into g of x for some polynomial g of x. And in this case, P of a, what is P of a? P of a equal to, substitute x equal to a. P of a equal to a minus a into g of a. We know a minus a equal to 0, so P of a equal to 0. So this is the proof of this theorem. Once again, factor theorem and its proof. These are very important, so you should take more care for this. So first one is factor theorem statement is P of x is a polynomial of degree n greater than or equal to 1 and a is a real number. Then first one is x minus a is a factor if P of a equal to 0. Second one is P of a equal to 0 if x minus a is a factor. P of x minus a is a factor if P of a equal to 0. P of a equal to 0 if x minus a is a factor. That is proof of this theorem. Proof. We are going to prove it with the help of remainder theorem. Firstly, by the remainder theorem, P of x equal to x minus a into q of x plus P of a. And if P of a equal to 0, first condition, if P of a equal to 0, then P of x equal to x minus a into q of x, which shows that x minus a is a factor of P of x. That is the first. Then second one is since x minus a is a factor, so P of x equal to x minus a into g of x for some polynomial g of x. Now in this case, P of a, put x equal to a, P of a equal to a minus a into g of a minus a equal to 0, so P of a equal to 0. So this is the theorem. Next we are going to examine x plus 2. X plus 2 is a factor of the polynomial or not. X plus 2. X plus 2 is a factor of x cube plus 2x square plus 5x plus 6 and of 2x plus 4. Question is x plus 2 is a factor of x cube plus 3x square plus 5x plus 6 and of 2x plus 4. So we are going to check x plus 2. X plus 2 is a factor of these two polynomials or not. So first we are going to take p of x. P of x equal to x cube plus 3x square plus 5x plus 6 and g of x equal to 2x plus 4. Examine whether x plus 2 is a factor or not. We know the 0 of x plus 2. What is the 0 of x plus 2? That we learned the previous class. 0 of x plus 2, that is x plus 2 equal to 0, x equal to minus 2. So 0 of x plus 2 is minus 2. 0 of x plus 2 is minus 2. Now we are going to find now p of minus 2. What is p of minus 2? P of minus 2 equal to minus 2 cube plus 3 into minus 2 square plus 5 into minus 2 plus 6, that is equal to, what is minus 2 cube? What is minus 2 cube? Minus 2 into minus 2 into minus 2. Minus 2 into minus 2 into minus 2. Multiply 3 times, that is minus 8. Then plus 3 times minus 2 square. Minus 2 into minus 2 is positive 4. 4 times 3 is 12. Then 5 times minus 2 is minus 10 plus 6. Here some negative numbers and some positive numbers are there. Minus 8 and minus 10, that is minus 18. Positive 12 and positive 6, it is positive 18. Minus 18 and positive 18, answer is 0. P of minus 2 equal to 0. P of minus 2 equal to 0. So x plus 2, it is a factor of this polynomial p of x. Okay. Now we are going to check the second polynomial 2x plus 4. So we are going to find g of minus 2. What is g of minus 2? G of minus 2 equal to 2 into minus 2 plus 4. What is 2 into minus 2? 2 into minus 2 is minus 4 plus 4, that is equal to 0. G of minus 2 also 0. So we can say that x plus 2, it is a factor of p of x, that is x cube plus 3x square plus 5x plus 6, and it is a factor of 2x plus 4. Okay, is it clear? Can you follow me? Okay, then consider the next question. We are going to find the value of k. Find the value of k if x minus 1 is a factor of x minus 1. It is a factor of 4x cube plus 3x square minus 4x plus k. 4x cube plus 3x square minus 4x plus k. We are going to find the value of k, and given that x minus 1 is a factor. X minus 1 is a factor. We have to find the value of k. How to find it? How to find this one? Okay, let us see its solution. Here we have to find the value of k. Value of the constant k. Given that x minus 1 is a factor. So we can say that as x minus 1 is a factor, x minus 1, it is a factor of x minus 1 is a factor of p of x equal to 4x cube plus 3x square minus 4x plus 4. It is a factor, so we know p of 1. What is p of 1? P of 1, x minus 1 is a factor, so p of 1 equal to 0. So then what is here p of 1? P of 1, put x equal to 1, 4 into 1 cube plus 3 into 1 square minus 4 into 1 plus 4. As we know, x minus 1 is a factor of p of x. As x minus 1 is a factor of p of x equal to 4x cube plus 3x square minus 4x plus k. Then we know p of 1 equal to 0. X minus 1 is a factor, so p of 1 equal to 0. Now p of 1 equal to 4 into 1 cube plus 3 into 1 square minus 4 into 1 plus k. that is 1 cube. 4 into 1 cube, 1 into 1 into 1, that is 1. So 4 into 1 is 4 plus 1 square. 1 square is 1 into 1, that is 1. 3 into 1 is 3. Then minus 4 into 1 is 4 plus k. Now 4 and minus 4 cancel. We got 3 plus k. P of 1 equal to 3 plus k, and we know P of 1 equal to 0. So equating 0 equal to 3 plus k, or k equal minus 3. So this is the value of k. Is it clear? Once again, x minus 1 is a factor, or so P of 1 equal to 0. Now we are going to find a P of 1. Given polynomial as P of x equal to 4x cube plus 3x square minus 4x plus k. Now P of 1 equal to 4 into 1 cube plus 3 into 1 square minus 4 into 1 plus k. That is equal to 4 plus 3 minus 4 plus k. 4 and minus 4 0. 3 plus k, but we know P of 1 equal to 0, 0 equal to 3 plus k equal to minus 3. Now, next problem, we will now use factor theorem to factorize some polynomials of degree 2 and 3. You are already familiar with the factorization of a quadratic polynomial like x square plus lx plus m. You already learned this thing, learn how to factorize this quadratic polynomial, and you had factorized this x square plus lx plus m by splitting the middle term lx, as ax plus bx, so that ab equal to m. Then x square plus lx plus m, it is equal to x plus a into x plus b. This factorization you already learned from 8th standard. Now we shall now try to factorize some quadratic polynomials of the type ax square plus bx plus c, where a not equal to 0, a, b, c they are constants. Children, x square plus lx plus m, this type of quadratic polynomials you already learned how to factorize this quadratic polynomial from 8th standard. Now in this year 9th standard we are going to factorize some quadratic polynomials of the type ax square plus bx plus c. Here x square has a coefficient, here x square has a coefficient 1, here x square has a coefficient. Ax square plus bx plus c, a not equal to 0, a, b, c are constants. Such examples we are going to see how to factorize these polynomials. Okay. Let us consider an example. Factorize 6x square plus 17x plus 5. Factorize this quadratic polynomial by splitting method. Children, there are two methods for factorizing this type of quadratic polynomials. One is splitting the middle term, another one is by using factor theorem. So we have two methods to factorize a quadratic polynomial like ax square plus bx plus c. One is splitting the middle term, another one is by using factor theorem. So first one is by splitting the middle term, how to factorize this quadratic polynomial. Let us see. Its solution is we are going to split the middle term. What is the middle term here? We can see that middle term is 17x. So splitting the middle term, we have to write the middle term as the sum of two numbers. Middle term as the sum of two numbers whose product is AC, that is AC. So what is AC? Compare this with the general equation ax square plus bx plus c, and we are writing the middle term b. We have to write b as the sum of two numbers whose product is AC. So let us see how to write this one. Solution of this one, 6x square plus 17x plus 5. Factorize by splitting the middle term. So we can find two numbers p and q. Find two numbers p and q such that p plus q sum equal to, what is the sum? Sum equal to 17, and product pq equal, what is the product? Product of these two, 6 and 5, multiply these two, product equal to 6 into 5, 30. So we have to find two numbers p and q. What is the condition? Sum equal to 17 and product equal to 30. Product 30 and sum equal to 17. Then we can get the factors. So let us look for the pairs of factors of 30. Pairs of factors of 30. So some of them are 1 and 30, pairs of factors of 30, 1 and 30, 2 and 15, 3 and 10. What is the next one? Next one is 5 and 6. These are pairs of factors of 30. Now, of these pairs, we will get whose sum is 17. Check these pairs. From these pairs, which gives us sum 17. So we can take these two, 2 and 15, which will give us sum 17. That is 2 plus 15 equal to 17. So we can take these two, 2 and 15. So how to write this polynomial? So how to write this one? How to write this polynomial? So by splitting the middle term. So the given polynomial 6x square plus 17x plus 5. It is equal to 6x square plus how? 6x square plus 2x plus 15x plus 5. Split in the middle term. Middle term is 17x. 17x is the middle term, that is equal to 2x plus 15x. 2x plus 15x split in the middle term. So it is equal to, now it is equal to 6x square plus 2x plus 15x plus 5. Now we are going to find common factors. First we are going to make groups, first and second term, third and fourth term. So first and second, which are the terms in first and second? 6x square, we know 6x square, factors of 6x square is 2 into 3 into x into x. Is it clear? Any doubt? 6x square equal to 2 into 3 into x into x, and 2x equal to 2 into x. Now find the common factors. 2 is common, x is common. So we can take 2x outside. From these two, 2x outside. 2x into, it is 2x into, then what will be left? 3x. First term 3x plus second, what is left in the second? 1. So 3x plus 1 plus. Similarly, from the third and fourth terms, what is common? 15 and 5. We know 5 and 15. 15 is a multiple of 5. So we can write it as 5 is outside. 5 into, it is 15. 5 into 3. What is left? X. 3x plus, here what is left? 1. So 5 into 3x plus 1. Now we can see that 3x plus 1 is common. 3x plus 1 into 2x plus 5. So these are the factors of the given polynomial. Once again, polynomial is given 6x square plus 17x plus 5. We are going to factorize this polynomial by splitting the middle term. We know middle term is 17. Now we have to find some factors of 30. We have to multiply 6 and 5. That is product 30 and sum equal to 17. Product of two number is 30, sum equal to 17. So we know that 2 and 15, its a product is 30 and sum equal to 17. So we are going to select these two numbers, 2 and 15. So split in the middle term, 17x equal to 2x and 15x. 2x plus 15x. So middle term 2x and 15x. Now first and second term, from the first and second terms 2x common, that is 6x square equal to 2 into 3 into x into x, 2x equal to 2 into x, 2 is common, x is common, 2x is common, 2x outside, so 3x is first term, 1 is second term, so 3x plus 1 plus similarly third and fourth, 5 is common, 5 into 3x 15, 3 into 5 is 15, so 3x plus 1, 3x plus 1 is common, so 2x plus 5. So these are the factors of 6x square plus 17x plus 5. Is it clear? Okay. Now one more example. Now we are going to factorize a quadratic polynomial by using factor theorem. How to factorize it? Let us see. A question is y square minus 5y plus 6 by using factor theorem. Factorize this polynomial, this quadratic polynomial by factor theorem. How? First, how to factorize it? Solution. Let us see. First, we are going to take let p of y equal to y square minus 5y plus 6, and we are going to take now if p of y equal to y minus a into y minus b. If p of y, the polynomial is can be written as p y minus a into y minus b, then you know that the constant term, what will be the constant term? The constant term will be, what is the constant term? Constant term will be ab. So ab equal, what is ab in the question? What is the constant term? Constant term equal to 6. First, the polynomial is p of y equal to y square minus 5y plus 6. Now, if we write p of y equal to y minus a into y minus b, then you know the constant term will be ab. So here ab equal to 6, constant term is 6. So to look for the factors of p of y, we are going to look at the factors of 6. Which are the factors of 6? That you already know. Factors of 6 are 1, 2, 3. 1, 2, 3 are the factors of 6. Now what is p of 2? What is p of 2? P of 2 equal to, find p of 2. P of 2 equal to, put y equals 2. 2 square minus 5 into 2 plus 6, it is equal to 2 square. 2 square equal to 2 into 2 4 minus 10 plus 6. 10 is negative, 4 is positive, 6 is positive, so 6 plus 4. If these two are positive numbers, it is 10 minus 10, answer equal to 0. P of 2 equal to 0. We got P of 2 equal to 0. So we can say y minus 2. Y minus 2, it is a factor of P of y. Y minus 2 is a factor of P of y. Also P of 3. What is P of 3? P of 3 equal to, P of 3 equal 3 square minus 5 into 3 plus 6, that is equal to, what is 3 square? 3 square equal to 3 times 3, that is 9. 9 minus 15, 5 into 3 is 15 plus 6. Clearly we know that 9 is positive and 6 is positive. These two are positive numbers. 9 plus 6 is 15 minus 15. 15 minus 15, answer is 0. P of 3 also 0. So y minus 3 is a factor. So first we got y minus 2 is a factor. Secondly we got y minus 3 is a factor. Therefore P of y, that is the given polynomial y square minus 5y plus 6, it is equal to y minus 2 into y minus 3. Is it clear, children? Can you follow me? Any doubts? Okay, look once more. Polynomial is y square minus 5y plus 6. Now we are going to factorize this polynomial by using factor theorem. First, take it as p of y equal to y square minus 5y plus 6. Now, if we write p of y as the product of two polynomials y minus a and y minus b, then we know the constant term will be ab, that is equal to ab, and here ab equal to 6. Then we are going to find the factors of p of y, so we have to find the factors of 6. Factors of 6 are 1, 2, 3, and p of 2 equal to 0. So y minus 2 is a factor. P of 3 equal to 0, and then so y minus 3 is a factor. Therefore, the polynomial y square minus 5y plus 6 equal to y minus 2 into y minus 3. Okay, one more example. Now let us consider factorizing cubic polynomial. How to factorize a cubic polynomial? We have seen factorization of quadratic polynomials. Now let us consider factorizing cubic polynomials. Here, splitting method, that will not be appropriate to start with. So we need to find at least one factor first. Let us see one example. Factorize x cube minus 23x square plus 142x minus 120. We have to factorize this polynomial. It is a cubic polynomial degree 3. So it is a cubic polynomial. Factorize this cubic polynomial. As you know, splitting method is not appropriate to start with. So we need to find at least one factor. So how to find it? So we are going to take it as p of x. P of x equal to x cube minus 23x square plus 142x minus 120. Now, we shall now look for all the factors of minus 120. First, we shall now look all the factors of 120. Factors of 120 minus 120. Which are the factors of minus 120? Some of the factors are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 5, and plus or minus 6, plus or minus 8, plus or minus 10, plus or minus 12, plus or minus 15. Next one is plus or minus 20, plus or minus 24, plus or minus 30, plus or minus 60. These are some of the factors of minus 120. Now, we are going to check by trial. We are going to write P of 1. What is P of 1? P of 1 equal to, what is P of 1? Put x equal to 1. P of 1 equal to 1 cube minus 23 into 1 square plus 142 into 1 minus 120. What is the answer of this one? 1 cube is 1 minus 1 square is 1. 23 times 1 is 23 plus 142 minus 1. Some numbers are negative and some numbers are positive. 1 is positive, 142 is positive. These two are positive. So 1 plus 142 is 143 minus 23 and minus 120, they are negative numbers, that also minus 143, answer equal to 0. P of 1 equal to 0. By trial, P of 1, we got P of 1 equal to 0. So what is that? If P of 1 equal to 0, we can say what is x minus 1 is a factor. So x minus 1 is a factor of this polynomial P of x. First, P of x is the given polynomial, and we by trial we got P of 1. P of 1 equal to 0. So x minus 1 is a factor. Now how to do? We got one factor x minus 1. The next step is we are going to divide the polynomial by x minus 1. Divide the polynomial by x minus 1. That is x cube minus 23x square plus 142x minus 120 divided by x minus 1. Divide this polynomial x minus 1. That division we discussed in the last class. Have you remember? Okay. Now we are dividing first term divided by first term. X cube x cube divided by x. That is x 3 times, x 1 time. So 1 time cancel, x square is left. So write x square into x is x cube. Then minus 1 into x square is minus x square. Subtract minus plus, subtraction. Sign will change. It is 0. It is minus 22x square plus 142x minus 120. Okay. Now the new dividend is minus 22x square plus 142x minus 120. Now we are going to divide the first term of the dividend by first term of the divisor. Minus 22x square, that is minus 22x square divided by x. X square, x 2 times and x 1 time. So divide, quotient is minus 22x. Right, minus 22x. Now we are going to multiply these two, minus 22x and x, that is minus 22x square and minus 22x and minus 1. What is the product of these two? That is equal to plus 22x. Now we are going to subtract, sign will change. This 0. It is, what is this one? It is 120x minus 120. Now we are going to divide the new dividend, minus positive 120x by x. X cancel, 120 is left. So 120. Multiply 120 times x is 120x minus 120 into 1 is 120. Subtract. Remainder is 0. We got remainder 0. Now x square minus 22x plus 120. X square minus 22x plus 120. It can be factorized either by splitting the middle term or by using factor theorem. Now we are going to factorize this quadratic polynomial by either by using by splitting the middle term or by using factor theorem. Now we are here we are going to use split in the middle term, that is, what is the middle term? Middle term is minus 22x. Minus 22x and the product is 120. Product, that is PQ. PQ equal to 120 and sum equal to P plus Q. P plus Q equal to minus 22. So we have to find such numbers. Two numbers, their sum is minus 22 and the product is 120. So first we are going to find that factors of 120 factors of 120, we know the factors of 1 and 120, 2 and 60, 3 and 40, 5 and 24, etc. And we are 10 and 12. 10 and 12 product is 120. And if it is minus 10 and minus 12, what is minus 10 and minus 12? Sum equal to minus 22 and product is 120. So we are going to take these two, minus 10 and minus 12. So split in the middle term, minus 10 and minus 12. So the middle term 22x, that is equal to x square minus 10x minus 12x plus 120. Middle term, split in the middle term, minus 22x as minus 10x minus 12x. That is equal to, now we are going to group first and second terms, third and fourth terms. Then this is one group. So x square minus 10x, what is common? X square minus 10x. X square and 10x, common is x. We know x is common, x into, then here what is left? X. X minus, here is 10. X minus 10. X into x minus 10. Then third and fourth, what is common? Minus 12x and plus 120. 12 and 120, what is common? Minus 12 is common. Then x is out, left. X plus, here what is? X minus 10. X minus 10. Once again, first and second x is common. X into x minus 10. Third and fourth, minus 12 is outside. Minus 12 into x minus 10. Now x minus 10, x minus 10. X minus 10 is common. X minus 10 into x minus 12. we factorize this quadratic polynomial as x minus 10 into x minus 12. So the given polynomial p of x. So we can write p of x as, so p of x equal to, that is x cube minus 23x square plus 142x minus 120, that is equal to, firstly we got x minus 1. X minus 1 is a factor, x minus 1 is a factor, x minus 10. X minus 10 is a factor, x minus 12 is another factor. So we got the factors of p of x. P of x equal to x cube minus 23x square plus 142x minus 120 equal to x minus 1 into x minus 10 into x minus 12. Is it clear? Once again, this is the polynomial x cube minus 23x square plus 142x minus 180 is a cubic polynomial. We are going to factorize the cubic polynomial. And we know, firstly, by splitting method is not appropriate to start, because this is a there are 4 terms. So how to do? We need to first find one of the factor. So by trial, we are going to find one of its factor, and we have seen that p of 1 equal to 0. P of 1 equal to 0, so x minus 1 is a factor. Now we are going to divide the given polynomial by x minus 1, and we got the remainder 0, and x square minus 22x plus 120 is the quotient. And now we factorize this quadratic polynomial x square minus 22x plus 120 either by splitting the middle term or by using factor theorem. Here we done by splitting the middle term, minus 22x sum equal to minus 22 and product is 120. So we got two numbers, minus 10 and minus 12. Minus 10x and minus 12x. Here first and second x is common, x into x minus 10. Third and fourth minus 12 is common, x minus 10. X minus 10 is common, x minus 10 into x minus 12. That is, so we got the factors of polynomial p of x as x cube minus 23x square plus 142x minus 120 equal to x minus 1 into x minus 10 into x minus 10, x minus 12. I hope all the students understood the class. See you again. Bye bye.